In our first video on graphing rational functions, we looked at how to find any domain restrictions. Where will the graph have a vertical asymptote or a hole in the graph? In today's lesson, we're going to do two things. We're going to find any zeros or x-intercepts of the function, and we're also going to find the y-intercept of the graph if it has one. Okay, how do I find the zeros or the x-intercepts of a rational function? Well, the zeros of a function are the values of x that make f of x or y equal to 0. Since we're dealing with a rational function, we should ask ourselves the question, when is a fraction equal to 0? Well, let's explore. If I had something like 3 over 0, what does that equal? Well, what can I multiply 0 by to get 3? And the answer is there isn't anything I can multiply it by, so this expression is undefined. I know that if I have something like 8 divided by 4, that equals 2 because 4 times 2 gives me 8. Let's look at what happens when there's a 0 in the numerator. So what can I multiply 5 by to obtain 0? And the answer is 0. So to find the zeros of a rational function, I simply have to set the numerator equal to 0. When will negative 7 equal 0? Well, the answer is never. So if I have a constant in my numerator, then there are no rational functions of the 0. I'm sorry, if I have a constant in my numerator, there are no x-intercepts for the rational function. Let's take a look at that. And I can see by the graph here that the graph never crosses the x-axis. In our next example, we have some factoring that we need to do. So we said that the zeros of a rational function will be the values when the numerator equals 0. So this difference of 2 squares factors into the quantity x plus 2 times the quantity x minus 2. I need to factor the denominator in case they have any factors in common. So it looks like this will be x plus 4 times the quantity x minus 2. Well, I know that the numerator will equal 0 when x equals negative 2 or positive 2, but the factor x minus 2 is a common factor, so I know I have a hole there. So x plus 2 equals 0. So x equals negative 2, and I have an x-intercept at negative 2 comma 0. If the numerator and the denominator have a factor in common, then there is no hole at that x value, so it will not be a 0. Let's look at the graph of that. Okay, we see at positive 4 we have a 0 over here. There was not one at negative 2. And if I zoom out here, even though it looks like the graph is perhaps crossing the x-axis, I'm going to do a window zoom and a zoom box to show you what's happening here. If I box this out, I can see that it's right above the x-axis. All right, let's look at our next example. Again, we have some factoring to do. So my numerator is a difference of 2 perfect squares, factors into the quantity x plus 1 times the quantity x minus 1. My denominator factors into the quantity x plus 2 times the quantity x minus 2. So the zeros of this rational function will be any values of x that make the numerator equal to 0. So I get x plus 1 equals 0, x minus 1 equals 0. So I see that I have x equals negative 1 or x equals positive 1. So I have an intercept at negative 1, 0 and 1 at 1 comma 0. Since there were no common factors in the numerator and denominator, I don't have any holes. Let's see what that looks like. That is not the right function. So I have to put that in there. Here, one more to see if it's in there. There it is. All right, and I can see by the graph that it crosses the x-axis here at positive 1 and here at negative 1. Just as we expected. Now we've looked at how to find the x-intercepts of a graph. So a rational expression will equal 0 when its numerator is equal to 0. So we need only set the numerator equal to 0. Before doing that, however, we have to remember to factor the denominator in case there are any removable discontinuities. The y-intercept. How do I find the y-intercept? Well, the y-intercept hasn't changed what it's been since you've started studying it in Algebra 1. The y-intercept is the value of y when x equals 0. So we have y equals negative 7 divided by 2, looking at x equals 0, plus 3. I get y equals negative 7/3. So it's approximately negative 2 1/3. Let's look at the graph. I think this was our original graph. Here we go. And we see if I go to menu and trace and graph trace, and I let x equal 0, I see right here, I have my y-intercept, and my y-intercept is at the point 0, negative 2 1/3 or negative 7/3. Now, that concludes our lesson for today. So if you need more help on finding the domain restrictions, which is what we covered that in rational functions, graphing rational functions part 1. Today we covered finding the x-intercepts and the y-intercepts. In our next video, stay tuned, we will cover finding the end behavior of the graph on either side of any vertical asymptotes. So how do you know how the graph of a rational function is behaving near the intercepts? See you next time.